Hello and welcome to Session 4, Clean, Transform, and Load Data in Power BI. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI. And today we're going to continue exploring our journey of data analysis using Power BI. So let's jump right in. In this session, we will learn about resolving inconsistencies like unexpected or null values and data quality issues. We're going to apply data shaping transformations to columns and table structures and apply user-friendly naming conventions. To start shaping data, we open the Power Query Editor by selecting the Transform Data option on the Home tab of Power BI Desktop. When working in Power Query Editor, all the steps that we take to shape our data are recorded. And each time the query connects to the data source, it automatically applies the steps so the data is always shaped the way that we want it. From here, we can see the Queries pane on the left and the Query Settings pane on the right. The Queries pane allows us to group, rename, remove, disable or enable or load our queries. The Query Settings pane allows renaming and shows all the steps for the queries in order they were completed. You can right-click or context-click a step and add a description so that you can record why the change was made, such as excluding a specific column or changing data type to support leading zeros, etc. Common transformations in Power Query Editor include renaming, removing columns, formatting data types, etc. The first step in shaping your initial data is to identify the column headers and names within the data and then evaluate whether they are located to ensure that they are in the right place. You can also add columns based on existing columns, create a column using the M language, or convert date-time columns to calculate age, duration in years, etc. We choose columns by going to the Choose Columns Go To Column button, which selects the columns we want. We don't want to keep the ones we don't need. So if we have a date time, but we don't need the date or time, we can change that data type to just date or just time. This will reduce the size of our semantic model. When choosing columns, you're explicitly naming them so the new columns in the underlying semantic model will not change what choices we have made. This is different from just removing a specifically named column. When you add columns, the default data type is alphanumeric. Take care to select the proper data type for your column to avoid issues. When we import data from multiple sources into Power BI Desktop, the data retains its predefined table and column names. We may want to change these names to a consistent format. We want to choose a format that's easier to work with and is more meaningful to our user. We use the Power Query Editor and Power BI Desktop to make these changes and simplify our data structures. Take steps like rename a query. It is a good practice to change uncommon or unhelpful query names to names that are more obvious or that the user is more familiar with. We can also replace values. We can use the Replace Values feature in Power Query Editor to replace any value with another value in a selected column. We can replace null values. Occasionally, we may find that our data sources contain null values, and we can use the Power Query Editor to find and address problem values in the column. We can remove duplicates. If we need to remove duplicates, we can remove duplicates from the columns and keep only the unique names in a selected column. There are some best practices for renaming tables and columns and values. The best practice is to give your tables, columns, and measures descriptive business terms and replace underscores with spaces. Be consistent with abbreviations. Don't make them too short. Any prefaces or words with the numbers and ID, we want to make sure we're using ID all capitals every time if that's what we choose. Excessively short abbreviations can cause confusion if they're not commonly used within the organization. With Power BI Desktop, you can connect to many different types of data sources, then shape the data to meet our needs, enabling us to create visual reports and share them with others. Shaping data means transforming the data, renaming the columns, the tables, changing the text and numbers, removing the rows, or setting the first row as headers, and so on. When we promote headers, it's a table that was created in Power BI Desktop. So we bring in a table and the first row is the column names and we get a generic column name numbered 1, 2, 3, 4. When we promote headers, we promote that first row up to the headers. When we rename columns, we might discover that one or more columns has the wrong headers, or the header has a spelling error, or the values have a spelling error. or the header naming convention is inconsistent or not user-friendly. Those are great opportunities to make a change. We also may bring in data where there's several rows of empty data by design. So when shaping our data, we might need to remove some of the top rows, for example, and make our report performant. Removing columns is a key step to our data shaping process. We want to remove any unnecessary columns. It is much better to remove columns as early as possible in the process, and removing the columns in the early stage rather than later will provide us an early performant report, and we can always go back in and change our applied steps to add columns back in if we need them. When importing a table from a data source, Power BI Desktop automatically starts scanning the first 1,000 rows. That is the default setting and can be altered, but it will detect the data types in the columns. Some situations might occur where Power BI does not detect the correct data type. Where incorrect data types occur, you will experience performance issues. So a best practice is to evaluate the column data in Power Query Editor before you load the data into the Power BI model. If you determine that the data type is incorrect, you can change it. You might also want to apply a format to the values in the column and change the summarization default for each column. Some of the implications for incorrect data types are that it will prevent us from creating certain calculations, deriving hierarchies, or creating proper relationships with other tables. For example, if you want to calculate the quantity of orders year to date, you will get an error stating that the order date and column type is not a date if it's not a date, which will end up in an error. So when we change the column type, we go into the data type header. We can change it in two places, in the Power Query Editor and the Power BI Desktop Report view by using the column tools. It's best to change the data type in the Power Query Editor before we load the data. And as with any other changes that you might make in Power Query Editor, the changes that we make to the column data type is recorded and saved, so we can edit that or audit that in the future. This step is called the change type, and it'll be iterated every time that data is refreshed. The ability to combine queries is powerful because it allows us to append or merge different tables and queries together. Combining tables into a single table is beneficial in circumstances such as the following. If we have too many tables that exist, and it's going to overly complicate our data model and make it difficult to navigate and work with. Or if we have similar tables that have similar roles. If a table has only one or two columns, we may want to add that to another table, or if we use several columns from different tables in a custom column. We can combine the tables in two different ways by merging or appending. Appending is when we add rows of data to another table or query. So for example, we could have two tables, one with 300 rows and another with 100 rows. When we append the queries together, we will always end up with 400 rows. Append queries will not remove duplicates. Append works best when the columns match exactly. However, if the column sources and the queries are different, append will still work, but it will create additional columns as needed for the sources. And if one of the sources doesn't have the same values as the other table, then we will end up with null values or empty cells. When we merge queries, we are combining the data from multiple tables into one based on a column that is common between the tables. This process is similar to a join clause in SQL. And essentially, we will be adding columns from one table or query to another table or query based on that column. So to merge the two, we have to have that column key between the two tables. We can also choose how to join these two tables together, a process that is similar to the join statement in SQL. These join options include the left outer join, which displays all the rows from the first table and only the matching rows from the second. We have the full outer join, which displays all the rows from both tables, and the inner join that displays only the matched rows between the two tables. Unpivoting is a useful feature in Power BI. We use this feature with data from any data source, but often from Excel. Unpivoting streamlines the process of creating DAX measures in the data later on. For example, if we unpivot the table shown here, we are taking all the distinct rows in a category name and turning them into columns. If the data that you are shaping is flat, in other words, if it has lots of detail but is not organized or grouped in any way, the lack of structure can complicate your ability to identify patterns in that data. We can use the pivot column feature to convert our flat data into a table that contains an aggregate value for each unique value in a column. Simply put, query folding means that the Power BI desktop engine doesn't have to do the work for certain transformations. It's done on the native data source rather than brought into Power BI. The guidance to remember is that if we can translate or transform into a select or SQL statement, which includes operators and clauses such as group by, sort by, where, union all, join, etc., we can use query folding. If we go to the View Native Query option and it's not available or not displayed in bold, then the query folding is not possible for that step, and we will have to work backwards in the Applied Steps area until we reach a step where we can view the native query. When we see that it's available, we can then open up and view that native query. This process will reveal the native query that is used to transform the semantic model. Native queries are not possible for the following transformations: adding an index column, merging and appending columns of different tables with two different sources, changing the data type of a column, or running complex DAX functions. By setting parameters, we can choose specific values we want to see in the report, and the report will automatically update and filter based on our selections. Imagine a sales analysis report. A use case for getting a parameter on the salesperson ID would be enable personalized analysis for different salespersons. By creating a parameter for the salesperson ID, users can then select specific salespeople from the drop-down menu or a slicer in the Power BI report, and then the visuals will change. The parameter value is then used in Power Query to filter all the sales data, including only the transactions associated with the selected salesperson, and allows users to focus on the individual sales performance, compare salespeople, gain insights to their respective contributions and overall revenue, and customer acquisition. When it comes to performance of our report and models, keep in mind the following. Not all data will be used later, so trim it now if you can. This is at the import step. We want to trim our data as much as possible. Additionally, remember to go back and remove unneeded data when we're further in the process. We're going to talk about going back and repeating these transformation steps as our data model matures. We want to check our data types. Before loading, always check the data types. Not only do we need the correct data type to avoid errors, but using data types for some values enhance performance. For example, using integers for IDs instead of strings, which they may come from a database that way, will actually improve the performance of our model. Cardinality is how many unique values there are in a column. The more unique, higher the cardinality, the worse the performance. So eliminating columns with unique values that are no longer necessary is important. Not all data also needs to be reloaded every time we refresh the data, so we can mark some data to not be reloaded, and this can improve our performance dramatically. Grouping allows logical separation when you have a lot of queries. We can right-click or context-click the query and select Move to Group. And we want to use parameters, so storing values for reuse in our transformations can also improve our performance. Let's go to Power BI and see data transformations in action.
All right, here we are back in our sales analysis, and we're going to do a couple different things to make our work easier. We're going to transform our data. We're going to open up our transform data here in a moment, and we're going to make all of our data usable. We're going to eliminate a bunch of things that we don't need to see. So let's open up our transform data, and we will start with our employee query. Okay, so one of the things that we're going to do is rename this to salesperson. I can double click this. I can do context clicking, but it's that easy. Now the name of the query is changed. The concept here is once we have imported the data, we can do whatever we want with the column names and all of that. We're not affecting the source. We're not live connecting to the source and making any changes there. So we want everything to look the same. So we've changed it to salesperson, but this is the employee table. And so we have quite a few employees who are not salespeople. Okay, so what we want to do then is filter this table so that we're only seeing salespersons. So if I go to choose column, I can do go to column, and you'll see here, I've got salesperson flag, and then we want to filter on true. There we go. All right. Quite a difference in the number of rows that are being returned. And you can notice now in our applied steps, we see that we have filtered our table. And we're going to see the query being built over here on the applied steps. The next thing we want to do is remove all of the columns that we don't want. So we're going to manage our columns. We're going to do choose columns, and we're going to choose the columns that we want to keep. Right? So we're going to unselect these, and we're going to keep some of them that we need. So we need the employee key, we need the employee national ID alternate key, and we need the first name, last name, title, and email address. So first name, last name, title, and email address. So we're under choose columns, and you'll see now we have a much smaller set of columns. And so by choosing the columns, we have removed other columns. And so we see over here, we have all of the columns listed here that we wanted to keep. And so when we go into this step, it's removed everything else. If we know of a column that we wanted to add back in, we would have to know the name of it to add it back in, or we could remove this entire step. It would add them all back in, and we could repeat the step that we just made. So the next thing we want to do is we don't actually need two separate columns for first name and last name. So we can select them and we can merge columns. And our separator is going to be a space. Now we have the merged and we have the first name, last name with the space. And as you can see, even with 3 letters or 3 names, there is a space in between. All right. And now we can rename that because merged column doesn't sound all that great. We can double click this and rename it to salesperson. There we go. That easy. And we have the renamed columns merged to salesperson. We can go back and see what we've done. First name and last name was merged together, and we can continue through all of the steps that we have done so far. Next, we have the employee national ID alternate key, and that is quite a column, and we're going to call that employee ID because that is actually what that maps to. But because it comes from a different table or query, it doesn't match what we have in other tables. Much easier to read so far. I've got the employee key, the employee ID, salesperson, their title, and their email address. We're going to refer to the email address as the UPN, which is user principal name. So user principal name is how we are going to do some of our work around filtering later on. So we're going to just call this UPN, and that makes sense to us as how we're going to filter. Email address, UPN is just much easier for us to work with as we get data from other columns. Next, we're going to go to the sales the DIM employee sales territory. And we're going to give that a better name too. We're going to call that salesperson region. So this is going to help us out a little bit more. So let's go in there, salesperson region. All right, already looking a little bit easier to read. All right, so what we're going to do here is we have a column header, and what we want to do is remove some columns. Okay, so we want to remove the last 2 columns here. We can select them together, and then we can remove columns. And now we have 2 columns left. We have our sales territory key and the employee key, and we can move on to the product. I'm just going to change that to product. And in our product table, all right, and now we want to filter this table. So we're going to choose columns, go to column. All right, and we are looking for finished goods flag. And this is what we want. We don't want anything unfinished. And we're going to set that to true. Finished goods equals true. Then we're going to remove all of the columns except for the following. So we're going to repeat the other step that we had earlier, which is choose columns. And this time we want to unselect everything. We're going to keep product key, English, product name, standard cost, color, and product subcategory. All right. And then we're going to remove everything else. The next thing we want to do is expand our product category. So we select this icon here, and now we can choose from the values that we want to keep here. And here we want to keep the English product subcategory, DIM product category, and we want to uncheck use original column name as prefix. That's going to help us with the naming here. So we want just 2 columns. We want English product subcategory name and DIM product. So uncheck all of them. English product subcategory name and DIM product category. And then uncheck to use the original column name as prefix. And there we have just the name here. So there's no original column name as prefix. And that would have been just a much more to deal with. So now let's do some more updates. We're going to take our English product name, simplify that into product, put a space in here for standard cost to make it a little bit easier to read, create some conventions. And also we're going to shorten this one to category. And you see the step being added, renamed columns. Next, we're going to look at the reseller query, which is called dim reseller. We're going to fix that by making that easier to read. And here we're going to keep reseller key, business type, reseller name, and the geography. So we only want 4 columns here, and we want so we see that whenever it's named like that, we know it's going to have a set of its own details in there. So let's open this up. And here we want to include only 3 columns, the city, the state, province, and the English country region name. And of course, we don't want that original column that's unchecked. And now we have these 3. Now, if you remember, under business type, we had the warehouse issue. When we went and looked under view, we saw that we had warehouse and warehouse. So what we want to do is do a replace values. So we're going to context click on the business type column header, and we're going to select replace values. And what we want to do is replace warehouse with warehouse, all one word. So warehouse 2 words with warehouse 1 word. Replace values. And in here, we want to replace warehouse with warehouse. We'll select OK. All right. And we can see that we've fixed all of the instances of that. Next, we're going to rename the columns. So business type, we're going to add a space. This makes it easier for us to work. We're going to reseller name to just reseller. And let's do state province name to state province. We're going to put a hyphen in there because it's state or province, not. And English country region name to country or region, right? So so the dim sales territory, we could probably rename that query too. We're going to call that region. So to wrap this up, we now have a much easier to read report. We have all of the steps that we have done. We can go through and continue modifying later if we desire to, but we have drastically reduced the size of our semantic model. We've put everything in a readable format. Everything matches up. So while we work with this later, we're not going to have to try to remember what some of the things mean. And everything that has the same name will have the same name in different tables. And that's going to bring us to the end of this demonstration.
This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.